In this video, we're going to talk about section 6C, specifically about standard scores and percentiles. But before we can get to standard scores and percentiles, we need to talk about the normal distribution. And the normal distribution is a way to describe the spread of data, and it is probably the most commonly type of data spread that you'll see in real life. So we say that something has a normal distribution if it's symmetric, same on both sides, and forms a bell shape. So a bell shape starts low, it gets big in the middle, and then it goes low again, so it's got a single peak. And at the top of it, we say that that peak corresponds to both the mean, median, and the mode of the distribution. And we'll see a picture of this bell curve here in a second. Kind of conditions for identifying when something might be normal. Typically with a normal distribution, most of the data values are in the middle, which gives us that well-defined peak. They're also spread evenly about the middle, so there's some big and some small that make it symmetric. It is rare to have data values that are either really big or really small, which is why everything's clustered in the middle, and the data can come from a couple different factors, which is why there's some spread to it. And this is a picture of what a normal distribution looks like, or a bell curve. You see it starts low, gets big in the middle, and then goes low again. In the middle, we label that value to be the mean. It's also the median and the mode, but typically we would just refer to it as the mean. And then going across the bottom, you see those funny little O symbols, the O with a hat? Well, that is the Greek letter sigma, and sigma represents a standard deviation. And for this class, what you need to know is that standard deviation tells us how spread out the data is. If there's a large standard deviation, that means there's a lot of spread to the data. If there's a small standard deviation, that means all of the data is clustered very tightly together. In this class, we're not going to calculate standard deviation, you'll be given it, but it's good to know what it is and where it comes from. Or if we do need to calculate it, we've got Excel, so we can calculate it in Excel. In Math 152, which is statistics, you'll see how to calculate the standard deviation and the mean by hand, but you don't need to do that for this class. So anyways, on our chart, we see that we have the mean in the middle, and then we're going out standard deviations. So we have plus one standard deviation and minus one standard deviation. What that says, if you go out one standard deviation from the mean, about 68% of the data lies between those 2 points. That's what we mean by most of the data is in the middle. Almost 70% of the data lies within one standard deviation of the mean. If we go out 2 standard deviations, above and below, we have 95%. And then if we go out 3 standard deviations, we have 99.7%. So almost all of the data is within 3 standard deviations of the mean. It's very, very rare for a normal distribution to have a point that is more than 3 standard deviations away. The way we see how far away a point is by calculating the standard score, or the z-score. The way we calculate a z-score is we take a data point, so we take its data value, and we subtract the mean from it. And think of that numerator as having parentheses around it because you want to do it first. So we do our data point minus the mean, and then once we do that, we divide it by the standard deviation. And again, what this tells us is how many standard deviations away from average a particular point is. It's a way for us to judge whether it's a big point or a little point relative to all the other points in the data set. So if our z-score is positive, that means that our data point is above average, so it's bigger than the typical point. If our z-score is negative, that means the data point is below average or smaller than most of the other data points. Let's look at an example. Let's say that we're doing a standardized test with a mean of 21 and a standard deviation of 4.7. A student takes the test and gets a score of a 30, and they want to know what is their z-score. Well, to calculate the z-score, we take our point, which is 30, we subtract the mean from it, so 30 minus 21, and then once we do that, we divide it by the standard deviation, which is 4.7. That gives us a value of 1.91. So if somebody gets a score of a 30, that means they're 1.91 standard deviations above average. That's really good. It's really good to be almost 2 standard deviations above the mean. It means that person did really well relative to everybody else who took the test. We're going to use these scores for some of our labs, specifically the steroids and baseball lab, but it's not actually going to be tested in this course. Those of y'all that go in and take statistics, you'll see z-scores a lot more in the future. Another concept is the idea of percentiles. And if any of y'all have children, or maybe you've taken end of grade tests recently, you've seen percentiles. A percentile tells you the percentage of the data that's at or below a certain point. So for instance, when Natalie went for her 4-month checkup, they told us that she was in the 30th percentile for weight. That means that Natalie weighs more than 30% of all other babies her age. So she's kind of a skinny little one. But they also told us that she was in the 70th percentile for length. So she is longer than 70% of all other babies her age. So she's kind of long and skinny, and if you see her daddy and me, we're kind of the same way. So I guess she's going to be that way probably most of her life. But again, the percentile just tells you the percentage of the data that's at or below that point. And we're going to calculate percentiles by using a chart. And if you need this chart on a test, we will give it to you. Or you're welcome to look it up in the PowerPoint or your book if you're doing a project or homework or something like that. But to use this chart, we just find our z-score and then we look beside it to see the percentage of the data that's below it. So in our previous example, the test had a z-score of 1.91. Well, the closest we can get is 1.9, and you see that a z-score of 1.9 means that we have 97.13% of the data below it. So our person that scored a 30 on the test did better than 97% of everybody else that took it. That's really good. It's really good to be better than 97% of all other people on a test. So that person should be proud of themselves. Couple more examples. Let's say that you score an 1850 on the SAT and your percentile or your score report says that you were in the 78th percentile. What this means is you did better than 78% of all other people who took the SAT. I think that's really good. I think that's something to be proud of if you did better than 78% of all other people. If you take it next year, even if you get the same score, you might not be in the same percentile because people will do a little bit differently on it, and some people might do better, some people might do worse, so your percentile could change even though you get the same score. So it all depends on who takes it next year. Let's say that your daughter's school mails you her end of grade report and you see she scored in the 85th percentile in math and the 67th percentile in reading. So what this means is she did better than 85% of all other students in her grade for math, and she did better than 67% of all other students in her grade for reading. I think that's really good. That tells you that she's performing way above average for both. It looks like maybe she has a strength in math, and if I were you, I would probably encourage my daughter's giftedness in math and maybe get her in like a math club or something. And in the 67th percentile in reading, that's still good. Maybe she has more room for improvement. Maybe take her to the library more this summer or something, but she's still doing really well, and I don't think there's any need to panic or stress out with these type of test scores. Those of y'all that have kids, you've probably seen this chart before. It shows you where the different percentiles are. So you take your baby to the doctor, they weigh them, and they put their age and then their weight on the chart, and you can kind of track where they fall on the different percentiles. It's kind of interesting to watch like Natalie's development. We're taking her back to the doctor in 2 more weeks. So I'm curious to see where she is at her 6th month compared to where she was in her 4 months, to see if she's gained weight or lost weight relative to other babies. She's definitely chunking up, but it'll be interesting to see how she compares to others. Another example. At Lydia's 1-month checkup, her doctor reports that she's in the 95th percentile for length. At her 2-month checkup, the doctor reports that she's dropped to the 85th percentile. In a panic, you say, oh no, she's going to be short. Well, is she? So at 1 month, she was longer than 95% of all other babies. At 2 months, she's longer than 85% of all other babies. She's still really long. She's still longer than 85% of all other babies. So she's definitely not short. Maybe she's not as long relatively, but she's definitely longer than most of them. There's no need to be concerned. Last example. At Jaden's 1-year well check, the nurse measures his head 3 times. Each time Jaden is in the 54th percentile. Well, this tells us that Jaden is very solid. His head is bigger than 54% of all other babies. So he honestly has a very, very typical head. About half the babies in the world have heads smaller than him, and about half the babies have heads bigger than him. So he's bigger than 54% of all other kids.